Hi, I'm Tanya Colonna. I'm the CEO of Blacktop Labs. We're working in personalized rehabilitation. I was born in 91, so when the Berlin Wall fell, I wasn't alive. When I was a child, I wanted to become an entrepreneur, and I co-founded Blacktop Labs with one of my best friends. And we are breaking the wall of personalized rehabilitation with the support of the SNN, the European Commission, and multiple business accelerator programs and business networks throughout Europe. Current methods of rehabilitation are often costly and inefficient, resulting in re-injury and wasted time and money, as well as a decreased quality of life. This is true for many types of rehabilitation. Let's take ACL tears, for example. When the ACL, which is a ligament in the knee or a band in the knee that provides stabilization, is torn, it requires surgery. After surgery, there's required 9 months of rehabilitation. However, after this 9 months of rehabilitation, there's a 30% chance of re-tearing this band within 2 years. This means that the patient has to start the entire process of surgery all over again. This adds an additional 20 million euro to the annual healthcare burden of the Netherlands alone. What causes this? Physical therapists believe that this inefficiency stems from an incompleteness in their return to daily activity criteria. There's something that they can't see or measure that is crucial in determining when a patient is fully recovered. Currently, physiotherapists can measure how much a patient can lift and how patients feel about their progress, but what they can't measure is how their bodies are actually responding to the load that they're lifting. This is important because each individual has a varied adaptive response to the loads on the body. This is the wall that we are breaking. Our device, the Gatekeeper, enables physiotherapists to see inside the muscles of their patient. They can measure how muscles respond to rehabilitation, and then they can personalize their training programs for the optimal adaptive response. We have medical-grade sensors that can be placed on specific muscles on the body that are crucial for any type of rehabilitation. These sensors detect muscle activity and movement patterns. We can track the adaptive response and muscle coordination patterns of 6 muscles at a time. Then our software algorithm interprets this data in order to provide actionable metrics for physiotherapists and trainers. This is all done wirelessly. We have been working with a top-tier physical therapy clinic here in the northern Netherlands to test over 70 patients throughout their ACL rehabilitation programs, and the results are very promising. Wouter Velling, a specialist on injury prevention and return to sport, says that our product could be the future of rehabilitation and training. Quantitative data is necessary for therapy centers to profit, to facilitate e-health, and for value-based reimbursement documentation. This additional metric could be the missing link needed to break down the wall of personalized rehabilitation. What we're doing is innovative because we're basically translating 70 years worth of EMG literature into a practical diagnostic decision-making tool. So what we do is we link the movement that you see into some type of measurement as to how your muscles are working. So we can basically calculate their efficiency. A proof of concept study has shown that this is important to track during ACL rehabilitation, and this concept is also scalable to movement disorders like Parkinson's disease, cerebral palsy, and ataxia. This is also crucial for elite athletic training. We're working with the Dutch Olympic skating team NextGen to examine their training technique and to provide data for diagnostic decision-making within their programs. Every time we speak to someone new in rehabilitation, in athletic training, or in exercise physiology, we think of a new way to use our device, and the opportunities are extremely scalable. Our device and our research benefits society because it provides the missing link to properly diagnosing what a patient is experiencing and tailoring a specific treatment plan or rehabilitation plan for that individual. Imagine having to fix a car but not being able to open up the hood to examine the root cause of the problem. Right now, this is how trainers, neurologists, and physiotherapists are expected to do their job. Our technology allows them to gather more data about what is actually causing the movement issues and to improve treatment, rehabilitation, and even athletic performance. So there are actually a lot of questions that remain unanswered, and the cool thing about our device is that it actually produces more questions because we're the first of our kind that can integrate into a clinical workflow, into an athletic workflow, and it doesn't really inhibit any movement. So we have 5 pilot sites going right now. One is testing how glute activation affects speed skating. Another, we're looking into the forearm activation within calisthenics. 2 of which are physical therapy sites where we're looking at quad and glute activation and rehabilitation and injury prevention in football, and also looking at muscle activation as a role in strength training. In 2 months, though, we're going to have a 6-sensor system. Right now, we have 1 sensor that can measure 1 muscle in isolation, but with the 6-sensor system, we can see 6 muscles in coordination, which is going to open up an entirely new ballpark of opportunities where we can answer even more questions. We're particularly interested into how we can help the movement disorder community. At the moment, though, what keeps us up at night is analyzing data, and we're very focused on finding a way to automate this process so that we can quickly provide value to new markets.